It's also known as a tare balance. It's also known as an electronic balance. And what it allows us to do is to weigh the chemicals that we're going to use in the laboratory. It has some interesting features that you've probably never seen before, and I'm going to introduce you to those. The first thing is that it has an electronic readout, and it actually weighs to tenths of a milligram. So it's an exquisitely precise instrument. It actually weighs down to tenths of a milligram. To give you some idea of how small a quantity this thing can actually weigh, what I'm going to do is I'm going to weigh this piece of paper, and then I'm going to write something on it, and then I'm going to weigh it again. And in the process, I'm going to demonstrate something called the tare feature, spelled T-A-R-E, which makes this a very convenient tool. So the first thing let's do is we'll put the piece of paper on. Actually, the first thing we should do is we should make sure that it's all on 0, 0, 0. And if it's not on 0, 0, 0, and it's fine, okay? So it's ready to go. So there's nothing on the pan, and the display reads all zeros. So we'll open the door, and we'll place the card on the pan, and we'll close the door. And now it reads out to tenths of a milligram, and eventually it's going to settle down. It bounces around a little bit, probably. Now, one interesting thing about the analytical balance is that it has a tare feature. And what that means is that we can now reset the balance to be 0. And the reason why we want to reset the balance to be 0 is what we're interested in is how much does the ink weigh on the piece of paper that I'm going to write. So in other words, we don't care about the piece of paper. And this is called weighing by difference. You could either write this number down in your notebook, and then when we weigh the paper afterwards, you could write the next number down, or you can use the tare feature, which resets the balance to 0. And now when I write something on the card and weigh it again, it's just going to weigh the ink that I've written on the card. Okay, here's the card, and the piece of paper is essentially accounted for already using the tare feature, and the ink weighs about 1.5 milligrams. So this thing can weigh 1/10 of a milligram reasonably well. I mean, it's settled down to, it fluctuates maybe 1/10 of a milligram. So it's actually pretty good. It weighs very exquisitely small amounts to reasonably high precision. Now, because it reads to such a high precision, even things like air drafts in the laboratory can affect how well it works. And to illustrate that, let me open the doors. Okay, so this thing is now settled down at, it's still wandering out a little bit. But in any case, it's on the order of 1 milligram. But if we open the doors, the air currents that are in the laboratory are going to cause this thing to wander around all over the place. And you can see that the numbers are just running amok, and that's mostly because of air currents that happen to be blowing through the lab. Okay, so let's now weigh something that you might be interested in weighing in the laboratory, and I'll show you a couple of techniques. These are called plastic weigh boats, and they are really convenient for weighing things, and you don't have to do anything with them. They're ready to go, but they're a little on the expensive side. The alternative to a plastic weighing boat is something called weighing paper, which is just very thin wax paper. Comes in a box, and you should always leave the lid on the box when you're not using the box. And the way you use weighing paper is you fold it in quarters, or at least in half, but typically in quarters. And then what happens is you've got sort of a little point in the middle, and the edges sort of cup up a little, and that way you can put the compound in the middle, and then when you want to transfer it, you've got a nice slot in which to pour the material out. All right, so let's use the weighing paper for this particular application. And you place the weighing paper on the balance pan, and then you slide the door closed, and you hit the tare button, and it's going to go to 0, 0, 0. Again, it's accounting for the mass of the weighing paper. If it doesn't go all the way to 0, 0, 0, just hit the tare button again. Okay, and now it's at 0, 0, 0. We're going to weigh out 100 milligrams of potassium permanganate. Okay, potassium permanganate is a very strong oxidizing agent. That's not important. Mostly why I chose it is because it's very highly colored, and this is a clean scoopula, and what you can do is slide the door open and take a scoop, and I'm standing off to the side a little, so it's a little awkward for me. You would typically be right in front, but you can transfer material to the center of the weighing paper, and if you want to sneak up on 100 milligrams, what you have to do is sort of tap the scoopula with your hand, deliver the solid. So we're at 62 milligrams, 88, 94. Oh, we've gone a little bit over. Now it's a good idea never to transfer reagent back to the original bottle. So I have a beaker here that I can transfer the excess reagent to. This is a clean beaker because I still might need some. And then what I'm going to do is take the piece of filter paper or the weighing paper out and put some back on my scoop and put the weighing paper back into the balance. And again, it looks really awkward because I'm standing on the side so that I can show you exactly what I'm doing, but if you were doing this for yourself in the lab, it would be a little bit easier. Okay. Now typically what you need to do in the lab, you don't have to weigh out an exact amount, you just have to know exactly how much you've got. And so we're just going to sneak up on 100 milligrams here and stop when we get close. What I'm doing is I'm tapping the scupula on the side with my finger to try to transfer little amounts of material, and that's probably going to do it. Okay. Now, to get the actual measurement, what you need to do, of course, is slide the door closed, and then you would record whatever value is read out here. In this case, it looks like 101 milligrams. Okay, 101.1. So it's now settled down. So that's how you would weigh something if you wanted a relatively small amount. Now, if you wanted a relatively larger amount, let me show you another technique. And you have to make a decision about whether you need a large amount or a small amount. Here's a weighing boat, and suppose we want to weigh out something like 5 grams of salt. Okay? 5 grams of salt. So we'll put the weigh boat in, and we will hit the tare button, and this is actually household salt. And you can just, instead of using the scupula, you can actually directly pour from the reagent bottle in. And it's a good technique to roll it from side to side. If you roll it from side to side, you get a lot more control over how much you're transferring. This is true of reagent bottles, and it's also true of things like salt shakers. To roll it from side to side. And we're going for 5 grams, so we're actually sneaking up. And now what I'm doing is tapping the reagent bottle or the reagent container with my finger to transfer little bits. And again, we're going for 5 grams, and we don't need to be exact, we just need to be close, and then we'll record whatever it's going to be. So I'm just rolling it ever so slightly to the side. Okay, so that's pretty good. Again, close the door, and once it settles down, you record the value. And this, in case, is 5.0183 grams. So, what have we done? I've showed you how to use the analytical balance. I've shown you how to use the tare feature. I've introduced you to the concept of plastic weighing boats and how to prepare weighing papers if you don't have... Oh, let me go back to the weighing paper just really quickly, and I'll show you this one last feature. Is because it's folded with a crease, it's possible to get all of the material down into the crease. In other words, the stuff is now sitting in the bottom of the crease, and if I need to transfer it to a beaker or something, for instance, the crease acts as sort of a chute, and that way, by tapping it with my finger, it's possible to transfer the material quantitatively to the beaker without getting it spilled all over the place. So that's why it's nice to have this little chute. In the case of the weigh boats, you'll see there's, well, first of all, it's possible to bend them, which is nice, so you can make a chute, but also they've got a little scooped out section in the corners, and so that allows you to make a nice bend so that you can transfer your material quantitatively as well. Anyway, so you're going to use this tool quite a bit in your laboratory, so get used to using it. Last thing I'd like to say is try to be neat, and if you make a mess, clean up after yourself. That's one of the ways to really destroy a very sensitive instrument, is to just leave a mess on the thing all the time. Some of the things you'll weigh really will be corrosive and caustic, and it's really important to take care of something that's as precise as an analytical balance.